Hi students, it's Mr. Nech, and today I'm going to be going over factoring polynomials. Okay, so in order to get through this homework, you're going to have to be very familiar with this thing called difference of squares. We're going to learn how to use this cross method for the trinomials that we see without a leading coefficient. And then we're going to learn the AC method and regrouping for trinomials that do have a number as a leading coefficient in front of the polynomial. All right, let's get started. So first, when you see a polynomial in your homework, you're going to factor out any numbers to simplify your expression. Then you're going to check for the difference of squares business. And that's going to be something like x squared minus 4, minus 9, 16, 25, 36, 49, 64, 81, 100, and so on. And these are your perfect squares. If you have no leading coefficient and it's a trinomial, you're going to check the x method. We're going to practice that, and then we're going to also practice our AC method with grouping. And that's what when you have this coefficient. A coefficient is a number. A polynomial means more than one term, and this is a trinomial with a leading coefficient of 2. The coefficient in front of the middle term is 3. All right, let's just dive right in. So number one, we had x times y squared minus x times z squared. So the question that you're asking is, what is the common term between both of them that can come out? And that would be x. And then you ask yourself, using division, if x comes out, because there's an x on both sides. So I can't take y or z because they don't have y and z on both sides. So when x comes out, this expression divided by x, you're left with y squared minus z squared, because I divided the x. And then, I didn't notice this at first, but this is a difference of squares that we were talking about. And this happens when the first and second term are perfect squares. And perfect squares would be like x times x, which is x squared, variable times variable squared, or 4, 9, and so forth, which is 3 times 3. So anyway, this is y plus z times y minus z. And if you FOIL this, you will see that the middle terms cancel out. The plus zy and the minus zy cancel out, and you're left with this. So we're good to go. This is a difference of squares, and I'm going to go quickly on it. If you don't understand, pause here and text me. Number 2. So here we're going to factor out our greatest common factor, which is 2. There he is. And what's left is x squared minus 2x minus 24. And then we have a trinomial with no coefficient in the front, so we jump to our x method. And how does this work? So this is our a number, our b number, and our c number. Okay? So a is 1. Anyway, so you're going to put your c right here at the top, and the outside number. The middle number, the negative 2, goes at the bottom. And the question we must ask and answer is, what two numbers multiply to negative 24 and add up to negative 2? So that would be negative 6 and 4. Because negative 6 times 4 is negative 24. Negative 6 plus 4 is negative 2. So then you're going to use these answers to fill out the binomials. And the 2 stays because it got factored out. So this is your final answer. 2 times x minus 6, close parentheses, open parentheses, x plus 4, close parentheses. Number 3 is very similar, and I want you to try it on your own. So what I did is I factored out the x, I jumped to the x method, what two numbers multiply to 10 and 7, that's 5 and 2, then I fill out my binomials. Oop, caught a typo, that should be plus 2, right? Right? X plus 5 and x plus 2. We learn together. Number 4, factor out a 2, and then notice this is a perfect difference of squares. So that translates into x plus y, x minus y. Number 5, I factored out a 2. And then I was left with this very interesting difference of squares. So the 9 is a perfect square because 3 times 3. X squared is a perfect square because x times x. So is 4 because 2 times 2. And it's a minus. So this difference of squares little shortcut only works when there's a minus. So how does that go? That goes into 3x minus 2 and 3x plus 2, and then the 2 still stays. Number 6, I factored out a 3, and then I had to use the x method to answer what two numbers multiply to 9 and add up to 10. That was 9 and 1. So our final answer was 3, open parentheses, x plus 9, close, open, x plus 1, close parentheses. So here's number 7. So what common term in this trinomial can we factor out? Greatest common factor was 2a. So what is left? X squared minus x minus 12. We have a trinomial, we go to the x method. And that leaves us with 2a, x minus 4, and x plus 3 as our two factors, with the 2a in front. Number 8. First things first, we're going to factor out our greatest common factor. So that's a 4. And then we're left with a squared minus 9, which is difference of squares. So that gets us to this final answer. Number 9. First things first, factor out a number to simplify our life. That number was 3. You were left with x squared minus 16, which is a perfect difference of squares. Don't forget the 3. Number 10. So factor out a 4. And what was left, go to the x method, fill out the x method, fill out your binomials. And this is your final answer, but I just want to let you know that x minus 5 times x minus 5 can also be written as x minus 5 squared. Okay, so number 11. This is where, in my opinion, it gets tricky, so pay attention. So if you've gotten everything up this far, you're doing great. So number 11, see how there's this 4 in front of my trinomial? That's what I call a coefficient and leading term, or in front of the trinomial or polynomial. And when you see this, you're going to have to do this AC method, which is very similar, but then we don't jump straight to this. We actually have to do our grouping method, which we did when we had 4 terms. And recall we were looking for something that's the same, like x minus 2, after we factor out a bunch of stuff, and then we regroup it. Anyway, let's try. So, first things first, greatest common factor. Can we take one out? Of course. 2. Boom. 2's busted out. What is left? 2 times x squared minus 3x minus 2. So the AC method, this is where it gets a little bit different. Instead of putting negative 2 at the top, you actually have to multiply a and c. So you have negative 2 times 2, which is negative 4. A is the first number, B is the second number, C is the third number. So the AC method tells us to multiply A times C, which is negative 4, and put that in the box, or whatever this x is. The middle number is still the middle number down here. So it still has to add up to negative 3. So then we ask the same question once we set up the x. What two numbers multiply to negative 4 and add up to negative 3? That would be negative 4 and positive 1. So watch what happens once you discover these numbers, how we apply them. So you're going to take your first term, 2x squared, and leave it. And then you're going to combine this negative 4 with an x and close your first set of parentheses. For your second set, you're going to take your second answer number with an x and then put the last number next to it. So you have 1x minus 2. Now, imagine when you had 4 terms, and remember when we just did parentheses and we were looking for a greatest common factor to factor out and then regroup? That's what you have to do. So what comes out of this? Well, a 2 and an x. And what comes out of this? Just a 1. Why do you need a 1? Because, well, 2x doesn't just stand alone. And do not multiply it with this coefficient on the outside, because this is part of this binomial. So if you follow the lines, the 1 and the 2x makes its own, and that was regrouping. And there's your x minus 2. As long as that's the same, that is one of the factors, and you did well. Okay? If you got stuck on this one, give me a text. Otherwise, let's keep going. So here we have a binomial, and first things first, what can we factor out? That's a y. What's left is a difference of squares. Eureka! We're pretty comfortable with that now. That's y minus 5 and y times y plus 5. Don't forget your coefficient that you factored out in the beginning. Number 13 is a straightforward x method problem. What two numbers multiply to, well, after you factor out an x? What two numbers multiply to 10 and 7? Those are 5 and 2. Number 14, factor out a 2. See what's left? That happens to be a difference of squares, so factor it accordingly. Number 15, factor out a 4. See what's left. That's a 12. Go to the x method. what multiplies to negative 12 but adds up to negative 1? Negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. Good to go. Make a binomial, 2 of them, with these answers. Number 16, I factored out an m, and then this was a difference of squares. You're pretty comfortable with that now? All right, last 2. So factor out a 2, and then go to your x method. What 2 numbers multiply to negative 4 and 3? Negative 4 times 1 is negative 4. Negative 4 plus 1 is 3. Uh-oh, found a typo. So I have to switch these signs. So that has to be a positive and a negative. See, this is the importance of checking your answers. If I didn't check my answers, this would have been a B quiz. Okay, so the final answer should read 2 times x plus, nope, plus 4 and x minus 1. So once again, that's 2 times x plus 4, close, open, x minus 1. Number 18. I was actually really nervous about this AC grouping method, but I think we finally got it. That's why I made the typo. Number 18. We factor out an a squared, because that's the commonality in all 3 terms. What's left would have been, or is, 2y squared minus 3y plus 1. Here we use the AC method, so 2 times 1, AC, that's 2. That's still negative 3, that's the middle term. So what 2 numbers multiply to 2? That's negative 2 times negative 1 is 2. And if we add these up, that's negative 3. You're good to go. A squared sticks around till the end. And then we have to do first term, 2y squared, minus 2y. So remember with the AC method, you have to add the y because it helps with the regrouping step. Then you have negative 1, but it's not just negative 1, it's negative 1y plus 1. And then remember, after you factor from both, you're supposed to be left with a common binomial. So that's my hint for you on this part, but here we go. The left one. 2y comes out, and what's left is y minus 1. Here, you have to change these signs because it's not exactly y minus 1, it's negative y plus 1. So in this case, you factor out a negative 1, which effectively and simply changes the sign on each term. So this turns into positive y and negative 1. And then that is your final answer. All right, I thought that was a wonderful lesson. I look forward to playing chess with you, and everybody stay safe.